All right, guys, are there any questions on the assignment so far? I'm going to end up writing that back again. So the assignment for yesterday was on page 311, 4 through 10 even, and 15 through 20. Now, what we're looking at today is logarithms. Now, logarithms are the inverse functions, or the inverse of our exponential. So log base b of y equals x if and only if b to the x is equal to y. So log base b of y equals x if and only if b to the x is equal to y. And b cannot be 1. The base cannot be 1. Because that's really doesn't mean a whole lot. And b cannot be 0. We don't deal with log of 0. So when we look at these first few here, we want to rewrite it from exponential, log base b of y equals x, from logarithmic into exponential, so b to the x is equal to y. Now in our first one here, log base 2 of 16 equals 4. Well, here our base, the value, or b is being represented by 2, 16 is represented by y, and x is 4. So we want to rewrite this as an exponential. We would say what? So 2 to the, because b is our 2, and it's to the x. Well, and here our x is what? 4. So 2 to the 4th is 16. And with these here, with these exponential ones, we can check to make sure we got it right. Because I can grab a calculator, clear this out, and say 2 to the 4th power is 16. So when I look at this here, 2 to the 4th equals 16. So we have this right. Let's look at the next one. So we have log base 4 of 1 equals 0. So here the value of b is 4. 1 is our y, and x is. So how would we rewrite this? 4 to the equals 1. Because anything to the 0 power except for 0 is 1. That's just our definition that we have with exponentials. Questions on this here? Are you ready for the next one? So we look at the next one. We have log base 12 of 12 equals 1. So how would we rewrite this as an exponential? And that's it. Questions on this here? Let's look at the next one. Log base 1/4 of 4 equals -1. What would we have? Questions on this here? Okay, let's look at the next one. So these 4 here, and then we'll move on to the next part. Log base 6 of 216 equals 3. So we would have 6 to the 3rd power is 216. Log base 7 of 1 equals 0. Log base 21 of 21 is 1. And lastly, log base 1/5 of 5 is -1. And anytime we have these fractions to an exponent, it's good to put it in parentheses around it. Any questions on any of this here? Okay. Now, we're going the other way around. Because up to this point, we've been going from logarithmic to exponential. Now we're going to go from exponential to logarithmic. So how do we think we would rewrite 5 squared equals 25 as a logarithm? Yes. Log base 5 of 25 is equal to, yes. B would be log base 10 of 0.1 is equal to -1. Questions on this so far? A to the 2/3 equals 4. So log base what? Of equals. Here, since we do have a fraction 2/3, we don't need parentheses around it because there's nothing, no exponent to it. We're not applying anything to it, so we can leave it as 2/3. How about the next one? Of any questions on any of these here? Let's do 4 more and then we'll move on. 9 squared equals 81. So what would we have? Log base of equals 20 to the -1st equals 0.05. So log base of 0.05 or 0.05 equals -1. Our next one would be log of equals 3/4. And lastly, log base of 325 is. Questions on any of this here? Questions on anything we've done so far? We ready for what's next? We want to evaluate this log base 4 of 64. So we're wanting to see what this equals. Let's rewrite it as an exponential to see if that helps. So if I rewrote log base 4 of 64 equals y, we would have what? To the y is equal to. So we're seeing what 4 to what power gives us 64. It'd be what? 3. Because 4 to the 3rd power is 64. Because if we did 4 times 4 times 4 multiplied by itself 3 times, we do get 64. Because 4 times 4 is 16, and 16 times 4 is 64. Which means log base 4 of 64 is 3. Questions on this here? Okay. Now we can do the same thing for the next one. Log base 5 of 0.2 equals x. So as an exponential, that would be what? 5 to the y or x, either one, yes, equals what? Okay. This is a little bit kind of harder to see. Let's change 0.2 to a fraction. What would 0.2 as a fraction be? 2/10 would reduce to. So we're trying to see what exponent I'm putting 5 to take it from 5 to 1/5, -1. Because anytime we move a number from the numerator to denominator or denominator to numerator, we change the exponent from positive to negative or negative to positive. Well, here, it's just 5 to the first. So if I move it up, it's just saying that exponent of 1 is actually -1. So 5 to the negative first is 1/5. So here it's just -1. Questions on this here? So really, if we're changing the number going from the numerator to denominator, denominator to numerator, whole number to fraction, or fraction to whole number, most likely that exponent's going to be what? Negative. Let's look at the next one. Log base 36 of 6 equals y. So if we rewrote this as an exponential, we'd have what? 36 to the equals. Okay. So what kind of operation would we need to do to 36 to get it to be 6? What do y'all think? Or how would I go from 6 to 36? Multiply by 6, which would be what? What operation? If it's not multiplication, division, addition, or subtraction, we would square it, because 6 squared is 36, yes? What can I do to 36 to get back to 6? Yeah, we would square root, because the square root of 36 is 6. How can I write that as an exponent? The square root of 36 is the same as 36 to what? 1 over 2, because our fractional exponents, because the square root is the same as the 1/2 power, which really is telling me what? Y is 1/2. So 36 to the 1/2, or the square root of 36 is 6. Questions on this here? Let's look at the last one here, or at least on this slide. So log base 1/5 of 125 is x. So if we rewrote this as an exponential, we would have what? 1/5 to the equals 125. Well, we know if we're taking the 5 from the denominator to the numerator, we're going to have to make the exponent what? Negative. So I can move it up. It's really saying that I have 5 to the negative x equals 125. So whatever our answer is going to be negative, because we had to move it from the denominator to the numerator. Anytime we're going from a fraction to a whole number to a fraction, whatever that answer is, most likely is going to be negative. Now the main question is, how many times do I multiply 5 by itself to get to 125? So the answer for this is -3. So log base 1/5 of 125 is -3. Questions on this here? Any question on anything we've done so far? So let's look at these here. So we have log base 4 of 256. We'll set it equal to x because we're trying to evaluate this here. Now if I rewrite it as an exponential, we would have what? 4 to the x is equal to 256. So here we're trying to see how many times do I multiply 4 by itself to get 256? And this here would be 4. Or we could have just kept dividing 256 by 4 till we get to 1. Either way works. Questions on A, how we got 4. Let's look at B. So if I rewrote this one as an exponential, we would have, what, 8 to the 0.125. Okay. Again, it might be easier to rewrite 0.125 as a fraction. Well, 5 is 1/8. So here we're saying 8 to the x is equal to 1/8. How can I move a number from the numerator to denominator? Negative. So it'll be negative. Did the 8 change value? No, it's still just 8, right? So it's going to be just -1. Because if we're just moving from the number from the numerator to denominator, denominator to numerator, it's really just going to be -1. Any questions on the first two here? Okay, let's look at the next one. Log base 1/3 of 27. 1/3 to the x is equal to. So what do we know about this value of this exponent? It's going to be negative, because we're moving from bottom of the fraction to the numerator. What times, or 3 to what power is 27? So log base 1/3 of 27 is -3. Because we're saying 1/3 to the -3rd is 27. Are you ready for the last one? So as an exponential, we have what? 64 to the equals, it would indeed be 1/2. Because if we're going from a bigger number to a smaller number, we're dealing with fractions. Because we're saying half of 64 is 8. Questions on this here? I'm going to throw one more in. Let's say log base 64 of 4. Well, this would be 64 to the x is equal to 4. I can tell you at this point it's not going to be 1/2. 4 times itself, how many times is 64? Well, hey, 4 times 4 times 4 is 64. So if I know 4 cubed is 64, what do we have to put 64 to? 1/3. Because the cubed root of 64 is 4. So if I have to cube it to get to 64, we would take the opposite operation, 1/3 of it, to get back. Questions on any of this here? All right. Now the other type of logarithm that we have is natural logs. And the natural log of y, let's make sure x, equals y if and only if e to the y is equal to x. Now, we don't write it in, but the base of the natural log is understood to be e. The base of the natural log is understood to be e. We don't write it in because it's understood. Just like we don't write every whole number as being divided by 1. We understand that as a denominator of 1, so we don't write it in. The same thing is true for our natural logs. We don't write in the e. Questions on this here? All right, we're going to rewrite these as natural logs, as exponential. So we're taking ln of x equals y to e to the y is equal to x. So here again, we have this understood e as the base. So how would I rewrite the natural log of 6 equals x? We would have e to the x is equal to 6. So it's almost the exact same thing we did with logs, except it's ln instead of log, and the base is understood to be e. How about the next one? ln of 5a equals b would be to the equals 5a. That's it. Be ready for the next one. ln of 42 equals b. So exponential it would be e to the b equals 42. ln of z equals 6. E to the 6 equals z. ln of 4y equals d would be e to the d equals 4 to the y. E, exactly, e to the e equals 3 to the a. I wanted to write, I actually wrote 3a earlier today. Wasn't paying attention. Is e to the e equals a. Any questions on this here? I think we're good with these here, yes? Oh, sorry. I was getting ahead of myself, because that's actually what I wanted to go to. Now, we're going from exponential to logarithmic. We're going the other way around. So this time we would be applying the ln. Thank you. So we'd have ln of what? Well, the base is e, yes? But as we said, it's understood to be e. It's always e with natural logs, so we don't have to write the e. Equals, yeah, ln of x equals 9. We don't have to write the e in. So e to the 4a equals c would be ln of is equal to 4a. Questions on this here? Let's look at the next one. E to the 2x equals y would be ln of, yes. E to the 57 equals z would be, yes. I think we feel comfortable with these here, but this would just be ln of 6 equals 9y, and this would be ln of 4 is equal to b. All right, the last thing we're going to cover. All ready for this? Well, not yet. So these here, we want to evaluate log of 8 and the natural log of 0.3. So in the calculator, we can go log 8 and hit enter. And we get 0.90308. And they wanted 3 decimal places. So log of 8 is 0.903. That's it. That's all we have to do. I think y'all like these, yes? Well, we can do the same thing for the natural log. And I'll show this one on the graphing calculator. Because if we do this here, so natural log is right there next to the 4, 0.3, close parentheses, enter. We get negative 1.2039, which would be negative 1.204. We can go log 8. You're welcome. Any other questions on these two here? Well, we can do the same thing with log of 98 and log of 9.8. And what would we get if we typed in log of 98? 1 point what? 9.1. And log of 9.8 is not 0. Yeah. 0.991. That's kind of interesting, isn't it? I mean, these two are essentially the same, but we just dropped the 1. How about the natural log of 7.84? Let's say 2. No, it might be 3. 0.059. And 79 over 2. 676. That's it. Let's see here. I think there's one that's kind of interesting is log of 1. What's the natural log of 1? Because if we rewrote ln of 1 as an exponential, that would be e to the anything to the 0 power is 1. So logarithm, no matter what the base, one of our properties that we have is that log base b of 1 is always 0, no matter what the base is. Because this is just saying b to the 0 power is 1. Anything to the 0 power except for 0 is always 1. So that's it. Questions on any of this here?